Hello factory fans, so you've made it to Gleba and you're naked and alone. There's crazy squid monsters all around you. What are you gonna do? This guide is going to show you how to sustainably produce iron and copper using biochemical processes on Gleba. Let's get cracking. You can build everything from scratch on Gleba, but it may take several hours, so ensure your Nalva space is self-sufficient and well defended. For a faster setup, consider a round-trip spaceship to bring supplies from Nalvas. Check out my spaceship guide on my channel for help with that. Now when you land on Gleba, we're going to need to unlock some key research. The first one is agriculture. To unlock agriculture, you need to just mine this iron stromatolite, and that's just basically these grey rocks you're going to find all over the place. So if you mine one, you can see it unlocks that key technology. Agriculture is going to give you the ability to build the agricultural tower and also be able to turn spoilage into nutrients. Since we're talking about spoilage, let's have a look at what that actually means. So most things on Gleba are actually organic, and you can see they all come with this like white bar underneath for freshness, and when that white bar reaches 0, it's going to spoil. It'll tell you how long it takes to spoil and what the result of the spoil is. So for example, this iron bacteria I'm hovering over at the moment will spoil soon into iron ore. And there it goes. So you can see the iron bacteria turned into more iron ore. Now, iron bacteria is a special case, but most of the fresh stuff on this planet will just spoil into spoilage. But if you happen to need more spoilage, you can just mine any of these like dead trees for spoilage. You should be able to get a lot of spoilage whenever you need it. This little area over here of dead trees already has like 400 spoilage in it. Now, when you have spoilage, you'll notice that we've unlocked another new process, which is the ability to turn spoilage into nutrients. Now, you can see you have some nutrients, and the nutrients freshness is going to go down real quick and turn straight back into spoilage. But this is going to be a very useful process to remember, that you can turn nutrients into spoilage. So whenever you do need some nutrients for whatever reason, you can just get it from spoilage, which you can very easily get from anywhere. Next, you're going to want to acquaint yourself with the two main natural resources of Gleba. The first one is Yumako. So look around your map for an area with a bit of green and then head towards that direction. In my case, it's down south. Now, once you reach this green area, look for a lighter green area. So for example, here, and inside the lighter green area, you're going to find these like highlighted white bits. Those are going to be your Yumako trees. They look like this. They've got these little red pods on them. And when you mine your first one, you're going to get access to Yumako, and a technology Yumako will automatically be researched. That tech will give you the ability to turn Yumako into Yumako mash. It also gives you the ability to create copper bacteria, but we'll go through that a little bit later. Now, your second basic resource is Jellynut. So look on your map for these purple areas, and if you can see any purple area with some white highlighted bits, you can head towards there and look for the jelly stem. So once again, at the purple area, the highlighted white bits, if you zoom in, you're going to see these jelly stem trees. Harvesting these jelly stems will give you the Jellynut, and it'll also give you technology Jellynut researched. The research will give you access to this new process that turns Jellynut into jelly, as well as creating iron bacteria. Now, I know all of these processes and resources are all a bit overwhelming right now, but I promise if you keep watching, it'll all be tied together real soon. Now, our first real goal on this planet is to get ourselves an infinite supply of Yumako and Jellynut. You don't want to be running around harvesting this stuff manually. You will have to run around harvesting it manually to get started, but we want to create a sustainable process to do this. So now it's time to put on our farming hats and build ourselves some agricultural towers. It requires steel plate, electronic circuits, spoilage, and landfill. Now, I'm going to leave the known resources up to you how you want to get it. You can either bring it in from Nalvas or you can farm it here locally on the planet. I'll just quickly go through how to get each basic resource, just in case you need to know. So we already covered iron. You can pick up iron from these grey rocks and they'll give you iron bacteria, which will eventually become iron. To get copper, just find these orange rocks, copper stromatolite. And if you mine that, you're going to get copper bacteria. So that'll turn into copper as well. And finally, to get stone, just look around on your map. If you just search stone as a resource, you can see there's actually just stone patches everywhere. Here, here, and here. You just mine stone like you normally do on any other planet. Now that you've got your stone, your iron, and your copper, you can figure out your basic power solution. You can either just do this boiler steam engine combo as you normally would on a new planet, or you can ship over some solar panels to get you started. By the way, if you need stuff to burn, you've obviously got your wood. But you've also can burn any of these biomaterials, Jellynut, Yumako, and if you look at the fuel value of something like Jellynut, for example, it's actually higher than coal, so keep that in mind. But however you choose to do it, Eventually, you're just going to try to build yourself 2 agricultural towers so we can get started on our Jellynut and Yumako automation. Now, once you finish building your agricultural tower, you just want to find yourself a fertile patch of Yumako soil. So that's this light green stuff amongst the darker green stuff. Preferably somewhere that already has a lot of Yumako trees so it can help you get kick started. When you found that area, just place down a agricultural tower wherever it lets you, and that it covers the most amount of Yumako trees available. So you can see this one's covering quite a few tiles. You can always fill in the rest of the tiles later using artificial Yumako soil, but we'll go through that in a bit. Now, once you run power to this agricultural tower, you can see it'll immediately get started on doing stuff, and everything it produces will go into this output section. Because I've built mine already where there are Yumako trees, it doesn't need to plant any seeds. It'll just start harvesting Yumako and Yumako will come out of it. Now, the next step in our process is to take the Yumako and turn it into Yumako mash. So you can see you can handcraft it, but obviously we don't want to do that. We want to craft it in a biochamber. So let's figure out how to make one of those. After researching agriculture and discovering Yumako and discovering Jellynut, the next thing that you're going to discover is the biochamber, and you can do that by crafting 10 nutrients. If you haven't already done so, you can just craft 10 nutrients out of spoilage. As we discussed earlier, you should have a lot of spoilage. Just craft yourself 10 and then it will unlock the biochamber research. Now, this biochamber is a really important building. It's going to basically do all of the biological processes on this planet. So we're going to need a few of them. We can see we're familiar with most of the materials required to craft the biochamber. The only thing we're not familiar with is the pentapod egg. That's a very interesting material. Now, if you want some pentapod eggs, you're going to have to go introduce yourself to the locals of the area. Just look on your map, look for some red, but nothing too big, otherwise you might get overwhelmed. Just a small group of pentapods somewhere and go have a chat with them. Hello pentapods, may I borrow some eggs? No, you don't like me borrowing eggs? Okay. Well, when you kill one of the nests, you can see the eggs are on the ground, but they also explode into a billion pentapods, so make sure you're ready for that. But here you go, you got a bunch of pentapod eggs on the ground now. Great. So we have a bunch of pentapod eggs. Beware, they do expire in 15 minutes, so make sure you have all of your other materials ready so that you can craft as many biochambers as you can. Now, there's a reason why you don't want to keep pentapod eggs in your bag. Look at the spoil result. They turn into giant packs of aliens. Crazy, right? So if you leave pentapod eggs in your bag, you'll just end up spawning all of these crazy pentapods after 15 minutes when they expire. So beware of that. Try to turn them all into biochambers. Obviously, biochambers are a building and they don't spoil. So now once you've got yourself a few biochambers, we can get on with the Yumako build. Now, as I explained before, this agricultural tower is going to harvest all the Yumako that it can reach, and it will output it in this output thing. So you can get it out just using your standard inserter. I recommend you grab the Yumakos and pull it away from your farmland. You don't want to start building your processing in the farmland because you're going to take up valuable farm tiles. So just like drag it out somewhere. I've dragged it out here, so I'm going to start my build just outside my farm area where there's some solid ground because I don't want to use up too much landfill either. A lot of this stuff is water, so you can't build on it. Now, I recommend you do all of your Yumako processing right next to your farm, and the reason for that is if you notice the actual process for Yumako mash, not only does it create mash, but it also creates the Yumako seed, which you need to reinsert back into your agriculture tower for it to continue to plant new Yumako and keep this whole process flowing. So put down a biochamber, set the recipe to Yumako processing, and we'll figure out how to deal with the inputs and outputs. Now, the first input is pretty straightforward. You just need the Yumako itself going in. So just hook that up, get some power to it, and we've got Yumako going in. Great. Now, it's also complaining that it's out of pizza. So what is this pizza thing? All biochambers actually require nutrients to function. Nutrients is the Factorio term for this pizza icon. So how do we get nutrients? Well, we've already kind of learned how to get nutrients, and we can make it from spoilage, for example, but let's have a look at what other ways we can make nutrients. Let's put down another biochamber and have a look at the recipes. Well, it looks like there's 3 ways to make nutrients. We can make nutrients from spoilage, we can make nutrients from Yumako mush, or we can make nutrients from Bioflux, and we don't know what that is yet. So out of these things, the most obvious thing to see here is to go, all right, why don't I make nutrients from Yumako mush since I'm making Yumako mush right here? If I put in some nutrients, you can see I've got the Yumako mush right here. So it makes sense to chuck that Yumako mush into another biochamber and get that making nutrients. That way, these nutrients can now feed both of these systems. You can see when you set up any sort of biochamber, you always need to jumpstart it with a bit of nutrients, which is super annoying, but we have to work around those challenges. Great, so we have some nutrients. We can jumpstart this nutrient creation process, and you can see it's eating these nutrients and creating these nutrients, but stupidly enough, these nutrients don't feed back into itself. So you have to create that process yourself. So for example, I can output the nutrients over here, I can run a belt downwards, and I can pull the nutrients back into the system. That way it'll keep the nutrients going and it'll keep making more nutrients. And these more nutrients can feed back into this biochamber that's making the mash, and the mash can feed back into this biochamber making more nutrients. Excellent. Now you think it's pretty straightforward. Now you just have to output the results of the mash into a belt and then split it so that the mash goes back to your main base and everything else goes into a separate box, the everything else being the seeds. So you can just do something like this and feed the seeds back into your agriculture tower, and you think that's pretty much it and you're done, right? Here you can see I've set up the system to do just that, where we've got our Yumako mash being sent over here. Well, it should be being sent back to the main base, but over here we've got our seeds going into this box, and our seeds are feeding back into the agricultural tower. The input is fully loaded with seeds. It's now planting more Yumako trees, and our cycle is complete, right? We've got new Yumako coming in, we've got the seeds separated going back to plant more Yumako, we've got our nutrients all set up, it's going to be fully fed and awesome, and we've got Yumako mush coming out and being sent all the way back to our main base, and everyone is happy. But very soon you're going to realize everybody is not happy, because we are on Gleba, and all of these items you see on these belts, as well as all of the items you see inside these biochambers, have a spoil timer, and left alone they're just going to eventually spoil on the belt, clog up the entire system, and everything will break down and stop working. You can see when your belts are backed up, all of a sudden all your stuff is spoiled and everything backs up. Your machines are now all craving pizza and they're not happy because we've run out of pizza, and now everything has spoilage in it. So we've got spoilage in our machines, we've got spoilage on our belts, we've got spoilage in our chests, and nobody's having a good time. Now, because it takes so long for any given thing to actually spoil, to demonstrate these processes are robust, I've decided to do all of this in a testing environment. So we're going to go jump over to a creative mode where I can fast forward the gameplay, so that way we can test and ensure that anything that we build is going to work for hours and hours and not just back up and create spoilage. Oh look, my pentapod eggs just expired, and you can see they spawned a bunch of stuff that comes and kills you. That's also fun. Now the test bench that I've set up here is exactly like what we see on the planet, but I've just sort of abstracted the process. So you've got your little farm here farming the Yumako trees. That's being output onto this belt, which is inputting into our Yumako process that I showed you earlier. So it's a biochamber that's turning the Yumako into mush, and that's feeding into a biochamber that's turning the mush into nutrients, and nutrients is being reverse fed back into here, and then our mush is coming out, our seeds are being pulled out of it and being filtered back into our agricultural tower to create more Yumako trees. And while everything is flowing, you can see it kind of works, right? But the problem happens when things stop flowing, and you can't guarantee that your mash is always going to be consumed and that your belt won't be full. So for example, if I remove this and our belt starts backing up, and then I increase the time to 64 speed, you can see everything very quickly expires. It all turns into spoilage. When that turns into spoilage and everything in here turns into spoilage, you will no longer be able to continue the process. Even if you start trying to clear this belt out, you can see even after clearing the belt, this process is never going to restart itself until you put in more nutrients. And you definitely don't want to be coming here to reload nutrients every time your process stops itself and coming to clear all the spoilage of the belt. So let's quickly go over what additions we need to make to a build like this to get all that handled automatically and ensure we always have a constant flow of Yumako mush out, even when the belt is full. Now, right next door over here, you can see I've got pretty much exactly the same setup. I've just made a few additional modifications, which I'll go through in a second, to ensure that this thing never clogs up and nutrients never stop being fed into here. So here, I'm just going to show you how it works first. So at the moment, obviously it's flowing, everything is happy. When it stops flowing, if I go up to 64 speed, you can see eventually everything is going to spoil. But unlike this system, you can see the belts are never actually clogging up. Spoilage is being handled somehow. Nutrients are always going to be in there. It's never going to stop. And I can demonstrate that by, say, like it's been running for like 3 days spoiled right now, right? Fully backed up. If we need to start consuming the Yumako again, we can just do that. And you can see as soon as it starts flowing, the process just continues on like nothing ever happened. Essentially, we've made a system that can start and stop whenever it wants. It can spoil, it can stop, it can start again, and you never have to actually come here and add more nutrients or clear any spoilage. So let's go over each of the new additions and see what you need to do to get rid of all of the spoilage. Well, first of all, we recognize that there can be spoilage inside the system itself. So that's why we need these 2 long arm grabbers that are filtered for spoilage. They're going to take the stuff, put it onto this belt, and you can see it's being fed onto this belt, and it's going over here. Now that spoilage is just going into this building, and you might be asking, what the heck is this thing? This is the heating tower. So if you go into your technology tree, you can look at heating tower, and you'll get this just by mining your first copper stromatolite. What I'm using the heating tower to do right now, like the heating tower is basically a light version of a nuclear reactor. Instead of eating nuclear fuel, it eats biomatter and it creates heat, and you can use these same things as you do in your nuclear power setup to create power. But that's a little bit out of scope for now. All I'm using the heating tower to do is delete spoilage. So spoilage comes in, it goes onto this belt, it gets picked up and thrown into the heating tower for incineration. The next source of spoilage is spoilage at the end of any belt. If your system clogs up, your belts stop, and everywhere that a belt stops can start spoiling. So you need a spoilage collection arm at the end of every single belt. So over here, for example, you can see when this stuff spoils, the spoilage is going to be picked up by this arm, chucked into this box for a buffer, and then eventually thrown into a belt that feeds also into this incineration machine. Let me just demonstrate that real quick. See there, right there, how it's got picked up the spoiled stuff at the end, put it into this box, and then it chucked it into this incineration machine. So that's all the spoilage that's been dealt with. The other long-term form of clogging that can potentially happen is you'll notice that more seeds will be created than you will ever be able to consume in the Yumako planting process. So eventually your seeds are going to back up as well. No matter what storage system or belt system you have going, eventually it'll back up. So I've got this very simple green circuit logic to read the contents of whatever box you're putting your seeds in. It's basically then just going to check whether the seeds are over a certain amount, allowing free space in this box, and just taking the seeds to the same incineration place as your spoilage. Seeds are also a burnable material. And by implementing all of this, you've basically created a system that can output Yumako mash and never clog up, even if the Yumako mash is not being used. This system can be started up anytime and it will just start running. While it's not running, it'll just continue to consume this stuff and keep itself fed and nutrients in these chambers. It's also extensible, so you can just copy this and just add another one over here and just move all your belt cleanup stuff out to the left, and you should be sweet. Just to show you again, I'm going to let that run at 64 speed, and you can see it's never going to jam up. Especially when the Yumako is actually being used, it'll never jam up. But even if the Yumako is not being used, it'll never jam up either. So I've let that run for a little bit. We're starting to consume the Yumako, and the process kicks right off. No human intervention required. Now, a couple of side notes. You might be wondering, why am I not using this process that can turn the spoilage back into nutrients? Well, first of all, it heavily complicates this whole thing. For some reason, because the nutrients created from a second source will spoil in a different order to this, it's gonna struggle to get picked up by this arm because you've got nutrients spoiling in the middle of your belt because they're not all coming out in the same order and spoiling at the end. So my suggestion is don't overcomplicate your process by trying to turn the spoilage back into nutrients. Just burn it, because there's an interesting side effect that comes out of this. You can see I've let this run for a while, and that spoilage is actually maintaining this heating tower at 1000 degrees all the time. Even that tiny little spoilage, whether the system is running or whether the system is backed up, either way, your heating tower is going to be maxed out. Now, if you take a look at the stats on this heating tower, you can see it outputs 40 megawatts of heat. And you know what else outputs 40 megawatts of heat? It's this nuclear reactor. A heating tower works exactly like a nuclear reactor. So guess what, guys? You can just attach onto the back of this heating tower this thing. You can see after I let this thing run for a little bit and deleted my infinite power source that while this mash is being consumed, or even when it's not being consumed, either way, this thing's temperature remains at 1000 degrees while connected to a nuclear reactor style setup with 10 steam turbines. So it's outputting 60 megawatts of power just as a side effect of this process. Whether the process is being consumed or not, it just always maintains 1000 degrees. It's pretty crazy. It's a little cool side benefit. So sure, you can use your solar power to jumpstart this whole system or whatever other power source you have, but once you get this system going, after a while, once you get your heating tower to temp, you can actually just chuck on the back a bunch of steam turbines and heat exchangers, and you can get a permanent power solution out of this setup as well. But just to recap real quick, what we've created here is a system that never backs up and will infinitely create Yumako mash, and you can now pipe that Yumako mash back into your base, and we're going to use that Yumako mash later for further processing. As a side effect, we've also generated 60 megawatts of power for free. Also, it's completely extensible, so you just move all your collection processes out of the way a little bit to the left, and you can add as many of these biochambers as you need if you need more Yumako mash. Next, let's go over the Jellynut process. Now, you might think they work in the same way as the Yumako process, but unfortunately it doesn't, because we're missing one key ingredient. Over in the Yumako process, we were able to create nutrients on site near the farm because we have this ability to turn Yumako mash into nutrients. But Jellynut, unfortunately, isn't able to be turned into nutrients for some reason. So unfortunately, we're not going to be able to process this on site unless you want to ship nutrients across here, which I highly don't recommend. So instead, what you're going to do with the Jellynut is build yourself an agricultural tower. You're going to run power to it from your base. You're going to have the Jellynut directly exported back to your base, wherever that is. And you're going to have another import lane for the Jellynut seed. And we're going to do all the Jellynut process in the base because we don't have access to nutrients out here. Alright, cool. So you set up your Yumako mash farm, you've set up your Jellynut farm, and now at your base, you have a constant stream of Yumako mash coming in and a constant stream of Jellynut unprocessed coming in. Now, the next step that we need to do is process the Jellynut into jelly. For our fuel source, we've set up this very simple setup over here that's going to turn all that mash that you're getting off site into nutrients. So it's basically two biochambers. It's doing the nutrients to Yumako mash process. So Yumako mash is coming in the back. I've got a very similar spoilage handling system where any spoilage that backs up in the system will be pulled out and into a separate belt. And we've also got the end of the belt spoilage handling mechanism, which is just an inserter filtered for spoilage. So if the process ever backs up and things start spoiling on the belt, they'll all be picked up and sent away. Where that's being sent away is just anywhere for now, but essentially it'll eventually lead over to some sort of incinerator, same as we had set up on our Yumako farm. Now, a couple of things that I just want to mention when I was trying to keep these processes alive. So first of all, the output of this nutrients is going to the end of the belt here and here, and I've got another inserter pulling from that same belt to keep nutrients going back into the machine. Additionally, just as an extra fail-safe, I've also got these two inserters filtered for nutrients to get nutrients between these two machines, just in case for whatever reason these two inserters fail to pick up a nutrient and your machine shuts down. This seems to work in practice quite robustly, so you can make your nutrient creation in pairs and you can extend all the way out this way for however much quantity you need. I'm going to show you all my examples with just two nutrient machines. Once you've got your nutrients set up, I'm feeding the nutrients onto a belt onto what is this like main bus style setup. So every ingredient that's going to be used further down the track will just continue to travel down this main bus. Now, the next step along the way is our Jellynut processing. So as you recall, we got our Jellynut farm and we've transported all of our Jellynut back to our base. We're going to peel that Jellynut off into our Jellynut processing area. The Jellynut processing area, I've just got the Jellynut and the nutrients forming one single belt, and that is being fed into the process. Now this processing will take Jellynut and it'll turn it into jelly and the seed. A very similar process to your Yumako mash process. For the output, I've got the spoilage handling, same as before, where spoilage is being pulled out of the machine onto a separate belt and out into our incinerator. We've got spoilage handling at the end of the input belt, so that anything that spoils on here gets put into the incinerator as well. We've got a separate arm over here that's going to pull out just the seed into a box, and that box is also got that same logic as our Yumako seeds thing, where if there's more than a certain amount of Jellynut seeds, that it's going to just put it onto some sort of belt that's going to take it into incineration. That should be reasonably robust. Just make sure you are taking stuff out from this seeds box and feeding it back to your Jellynut farm somehow, and feeding that back into your agricultural tower so that it always has seeds to plant more Jellynut to keep that process flowing. Now, at this point, this thing should be spitting out jelly on this side, and you can take that jelly and you can put it on your main bus. I've opted to combine my jelly and my Yumako mush onto a single belt, and you will see why in just a second. Now, because we've handled all our spoilage properly, this system of jelly will work exactly like our system of Yumako mash, and will continue to produce and never clog up whether the jelly is being used up or not. And if it does clog and all turn into spoilage, when it does start getting used up again, it will just declog itself without you ever having to feed it nutrients, because the nutrients is all handled up here, and this system will never clog up. So if you follow the steps so far, what you should essentially have is a main bus with Yumako mash and jelly on it, as well as nutrients for all our future processes, and none of these belts will ever jam up whether they're being used or not. So you might be asking, what's the next step? What am I doing with this jelly and mash? How is this jelly and mash going to turn into copper and iron? Well, I got you. The next step in our process deals with this thing called Bioflux. So if we head over to our technology tree and have a look at Bioflux, you should definitely have already unlocked this, because to unlock Bioflux, all you needed to do was craft a biochamber, and you should have crafted many biochambers at this point. Now, Bioflux is the foundation of all your raw resources. Firstly, it can create the iron and copper bacteria, which will allow us to create an infinite source of iron and copper. But additionally, later on, Bioflux is also used to create plastic, sulfur, and all your more complex processes. We will be focusing on how to turn our Bioflux into iron and copper. Now, Bioflux is made in, you guessed it, a biochamber, and it takes in mash, and it takes in jelly, and it creates Bioflux. Of course, it also takes in nutrients. So off our main bus, where I've combined the jelly and mash, you can see I'm just peeling it off, inputting it into the back. We've got nutrients peeling off the main bus, inputting into the back, and all of that is just being fed into the biochamber, and it's turning it into Bioflux, which is then being output back onto the main bus and continuing on for future processing. Now, off the back of this, we use exactly the same spoilage handling process as with everything else. At the end of each input belt, we have a arm that filters for spoilage, and it will send that off for incineration. And we've also got an extra arm that will pull any extra spoilage out of the machine itself and put it over here, which will get filtered for incineration as well, ensuring that this Bioflux process never backs up whether it's being used or not. Now on your main bus, you should have nutrients, jelly, mash, and Bioflux. So we can move on to the next step in this process. Now, earlier, you would have recalled that I showed you the spoilage process using iron bacteria. When iron bacteria spoils, it turns into iron ore. So essentially, to create iron ore, we just need to create an infinite source of iron bacteria. So let's go into our research tree to see how we might be able to do that. After crafting your first Bioflux, you unlocked this research called bacteria cultivation. Now, your bacteria cultivation is going to allow you to cultivate copper bacteria and cultivate iron bacteria. They're both very similar processes. We'll focus on the iron for now. The process itself takes one iron bacteria, one Bioflux, and it produces 4 iron bacteria. So you can already get a sense of how that is creating infinite iron bacteria, or a constant stream of iron bacteria, which essentially means iron ore. Now over here, I have 2 biochambers set up. They are both cultivating iron bacteria, which is that process that turns 1 iron bacteria and 1 Bioflux into 4 iron bacteria. Its input is just flux and nutrients. That's all you need to do. So you can just peel that off your main belt, and you can get that going into the back. You got to do the same spoilage handling processes, obviously, because everything in here can spoil. So you take any spoilage out and feed it into your incinerator. You also have to do the same spoilage handling processes we've done earlier at the end of any belt to ensure if any of the inputs spoil, it gets thrown into the incinerator as well. Once you've handled your input and spoilage stuff, we can look at the output. So the output of this thing is going to be iron bacteria, and the input is also iron bacteria. So whatever it outputs needs to be fed back into itself to keep the process going. So I've got my output. This works similar to the nutrients. I've got my output of iron bacteria or iron ore. over here, and it's going to feed through here, and then it's going to be picked up straight away to go back inside itself. Same with the second one, and I've just got 2 to feed iron bacteria between each other, just to keep that process more robust, to ensure there's always iron bacteria to cultivate. To get this iron bacteria working, you have to start priming it with some bacteria. So if you just go find some bacteria from a rock or something, you can kick off the process just by putting 1 bacteria into each one, right? Bacteria is being produced, it's being fed onto this belt, and whenever it needs more bacteria, it's trading within itself, and it'll just keep outputting iron bacteria forever, which is exactly what we want. Now, if we let this system run forever, this system is excellent. It just works forever. It's never going to die. It's never going to stop, right? It'll just keep going and going and going and going, and it'll produce you an infinite source of iron. You'd think we'd be done, but unfortunately, as I'd like to remind you, we are on Gleba, and nothing is ever quite this simple. Let's imagine a situation where whatever this iron is being used for example, you smelt it into iron plates, and then it's being fed into your shop or whatever. What happens when your iron plates back up and they're not being used anymore? Let's simulate that by cutting one of these belts and having the iron bacteria back up. You can see after a minute, the iron bacteria all turns into iron. That's fine. But what happens to this process? Well, this process, all the bacteria inside these machines have all turned into iron because they've all spoiled. And a copper bacteria only has a 1-minute lifespan, I believe. So very quickly, your iron bacteria in here is going to die. So your belt's now clogged up. And then let's simulate what happens when your iron is being consumed again, right? So now your iron's being consumed. It's going to offload the rest of this iron. But then these 2 processes are now stopped because there's no more bacteria in there, right? To start this process again, you need to go find more bacteria and come back here, manually load it up again, and get this process primed and kicked off again, and then it'll work again just like normal. But you don't want to be doing that. You might not be on Gleba. You might be on another planet. You might be on Nalbus. You don't want every time this belt backs up, these processes stop and then requiring some sort of manual intervention to get it going again. We need to create a system where whenever this belt backs up and the bacteria in here dies, somehow new bacteria can automatically get in here. So I've created a system like that. I'm just going to show you how that works now. Now, it's not a major complicated modification or anything. All I've done is add another biochamber and set the recipe to not the cultivation recipe, but the original iron bacteria creation recipe. The iron bacteria creation recipe takes in jelly and it turns it into iron bacteria. It only does it at a 10% chance, so the rest of the time it'll just turn it into spoilage. But it's fine, it doesn't really matter what that percentage chance is. Essentially, you just need to know that there is a process that turns jelly into iron bacteria. You let it run long enough, eventually it'll create 1 iron bacteria, and 1 iron bacteria is all you need to get this process up and running again. Now, you don't want this process running 24/7 because you only want this thing to run when these things run out of iron bacteria and the process needs to be kicked off again. So what I've done is I've run a green wire between here and here. You can see that wire is over here. And the green wire on this side is just to set to read contents. So it's going to read whatever's in here, 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 and here. And over here, it's going to enable or disable this machine. At the moment, you can see it's disabled by control behavior because the condition to enable it is that bacteria equals 0. So that's the key here. When bacteria is not existing in this process, then we're going to kick off this process to create bacteria. That's all there is to it. Of course, you need to have a jelly feed into it. So I've got this, our main belt jelly mash being fed into here. It's being peeled off this way to feed into this process. Of course, whenever you add new belts, you have to add new spoilage handling systems. So we got spoilage coming out of this system. We've got spoilage coming out at the end of this belt, tacking onto the same spoilage belts as here, going off into our incinerator. Make sure you, whenever you add new systems into your thing, you handle all the spoilage to make sure they don't break. Because I can tell you, this thing is not going to be running very often. You can see most of the jelly that's coming here is just being spoiled and then taken out. But anyway, this system is critical because let's simulate once again what happens when your belt is backed up. So here we are, our belt is backing up. Our bacteria has nowhere to go. It is slowly being pumped out here. The process has stopped. Our bacteria is no longer being inputted. This bacteria is slowly spoiling and very soon it's going to be completely gone. Okay, now this bacteria is spoiled into iron ore. That iron ore has nowhere to go. But hey, check it out. This thing is now kicked off. And look, it's created an iron bacteria. And that iron bacteria, well, it's going to spoil in here for now because this belt is still clogged. But guess what? This can be clogged for however long. It doesn't really matter, right? But say one day your iron is now being consumed again and this belt is now unclogged. Check out what happens. First, all the iron in these two empty out. But the iron bacteria that this thing produced has now fed into this system and kicked it off again. So that means this system is now able to start and stop whenever it needs to without any sort of intervention whatsoever. And that's exactly what we were looking for, because you can never guarantee that all your iron is going to be constantly consumed by your future processes. Now, copper works exactly the same way as iron, but of course everything is copper. So let's just go through it really quickly. So over here, we're peeling off the jelly and mash belt. Over here, where we're splitting the jelly off this side, we're splitting the mash over this side, right? So the mash is going over here. Any spoilage is being handled the same way. I'm not going to go through the spoilage handling process because it's happening the same across all of these systems. We've gone through it a billion times now. But basically, the mash is coming in, it's going into this copper producing thing. So this thing is creating copper bacteria. It's wired up with the same logic circuit as before, where it's checking, is the copper in the cultivation machines equal to 0? If it's equal to 0, I'm going to turn myself on and send new copper bacteria into the system. If it's not 0, I'm just going to sleep. The copper cultivation machine works exactly the same way as the iron cultivation machine. They feed into each other, they pull copper bacteria off the belt, and any excess copper bacteria just feeds off into your main bus or whatever the next process is that you're going to use copper in. But yeah, essentially it works the same way. So now you've got a constant stream of iron bacteria and copper bacteria coming out. What do we do with it? Well, it's all pretty straightforward. You can just feed it directly into a smelting column and eventually they'll just sit on this belt, turn into iron, and then the iron smelters can smelt it. What I've personally chosen to do is create this little marination circle. So the bacteria comes in. This side is filtered for iron ore only. So over here, it's going in, it's going to go into this belt where it just does loop-de-loops for a minute until it becomes iron. And once it becomes iron, you can see the splitter will then filter it and the iron itself will go into this smelting column. With the output of the smelting column constantly being trashed, these two machines can produce enough iron bacteria to keep 8 smelters active. If I put 2 more, you can see they won't work. Now, if we let that run for a while, we can see what that looks like. I'm just going to run this at 64 speed. So you can see it's roughly keeping about 8 active the whole time, 7.5. So you've got these 2 iron things outputting iron bacteria. They're going to go over here. They're going to marinate for a while, and then iron will constantly come out and go into this smelting column, and 8, maybe 9, maybe 10 smelters will continuously produce iron. A very similar thing over here for copper. So you got your copper bacteria coming out. It's going into this marination circle. It marinates for a minute and then it gets filtered, and copper ore goes into these copper smelters and they get smelted away as well. Alright, that was a lot of information to absorb, so I'm just going to summarize it all. So starting with our farms, let's assume this thing is your main base. Over here, you've got your Yumako Farm, which could be like somewhere far away. It doesn't really matter. But essentially, you get your Yumako Farm farming these Yumako plants. They are producing Yumako. The Yumako is going through our Yumako process, which is turning the Yumako into Yumako mash. Then we're going to take that process and we're going to feed it to our base. That could be quite a journey away from your farm. Like your farm could be down here and it could come in and feed Yumako mash to your base. Over here, we've got our Jellynut Farm, wherever that happens to be. It could be on the other side of the world, doesn't really matter. This Jellynut Farm will be farming Jellynut, and it won't be processing it on site. Instead, it'll send the Jellynut back to your base. Then you've got a Yumako mash and Jellynut feed in your main base. To start the process off, we're going to turn the Yumako mash into nutrients to feed all the future processes. So we've got 2 machines over here that are going to produce infinite nutrients. We've got proper spoilage handling, so they'll never back up and die. The next step in our process is to process all that Jellynut that we're bringing in. So we're bringing in the Jellynut, we're processing it. The seeds are being fed back out to our Jellynut farm to continue that process, and jelly is coming out of the Jellynut processing. Again, spoilage is being perfectly handled. All of this, while I'm talking, is running at 64 speed, so you can see it's continuously running. Once you've got your jelly and you've got your Yumako mash, you can combine those two to create flux. And flux is going to be used for all future processes. So we've got one flux machine currently producing flux, and that's being sent onto our main bus. With that flux, we are combining it with nutrients to send to these two processes, which are analogous for copper and iron. The iron process is using two biochambers to cultivate iron bacteria, and it's turning a small amount of iron bacteria into an infinite amount of iron bacteria. We've also got this extra iron cultivator to kickstart the process in case the belts ever jam. And we've got the exact same process happening for copper. We're sending that iron and copper bacteria out into some sort of marination process, and then when it turns into actual iron and copper ore, it's getting smelted in a smelting column, and there you have it. You've got your main bus for iron and copper. And just to prove to yourself no manual intervention is required, I'm going to delete these two consuming things and let this entire system back up, let all my bacteria die, and you can see for yourself that this process indeed works and will kickstart itself without any sort of player intervention. I think my copper bacteria has been left long enough. We haven't consumed copper or iron for many days now, and all of our bacteria in here is dead and has turned into ore. A few days later, we finally want to consume this stuff again. Okay, we're going to eat all the stuff on the belt. Great. Will our bacteria start again? Simple, right? As soon as we want to consume again, boom, it starts up the process again. I didn't do anything. I didn't cut the video. I didn't put any bacteria in. I didn't put any nutrients anywhere. The entire process just starts up again. Whether you're consuming the copper or not consuming the copper, whether bacteria is alive or dead, it doesn't matter. This system is robust. It can start, it can stop. You never need to be on the planet. You never need to do anything. You can just let it run. Oh, and let me remind you again, remember this process is happening on our farm, and inadvertently, to trash all that spoilage, we are maintaining a heating tower at 1000 degree temp, so that's giving you 60 megawatts of power. And over here on our main base, of course, we are also incinerating all that spoilage, so we are getting another heating tower with 1000 degree temp. I don't know how many heating towers this process can support. I'm assuming the bigger you scale this, the more heating towers you can support, so experiment and try it out. But yeah, this process, as a side effect, generates infinite power. Just putting that out there. But anyway, I hope you guys learned something from this video. I know these processes confused the hell out of me. I've created it all to be extendable to the right. So if you need to scale this up for whatever reason and produce more iron and copper, you can just scale up all of this to the right. And you should be perfectly fine. You can create more nutrients here, you can process more jelly here, you can make more flux, you can make more iron bacteria cultivation processes, you can make more copper cultivation processes. It's all extendable. Just make sure you've got your spoilage handling done right at the end of each belt. Now, if this guide helped you, don't forget to leave a like and subscribe, and I'll see you guys in the next video. In the meantime, you can check out my full Let's Play series where I bang my head against the wall trying to figure all this out.